Okay, here is an original effect that demonstrates the power of geometry. Now, for many students, if they have a favorite math class at all, it's most likely geometry. Okay, and that's what we're going to be using today to help us accomplish some amazing magic. So what I need you to do as the spectator, I need you to deal out 16 random cards, of which I will choose 12 of them so that this routine just doesn't take too long. Okay, so maybe you as a performer push off some from the top. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that feels like a good random selection there, and spectator can mix these as much as they would like. Now you as a performer just gather these up. Now you're not going to show, of course, the spectator what you're doing with the cards. You keep them in view so that they can see them, but you don't show them exactly which cards you're choosing. Okay, and I'll try to keep you from seeing what I'm doing, even though it's a little tricky to do with the camera right above me. Okay, so maybe I'll go with this one here. That's a good one. So I'm needing to choose 12, which means, let's see, 16 minus 12 is 4. So I should have 4 left, and then we'll be done with our selection process. Okay, and then maybe I'll choose that one, and then this one. And then these two look good. What else? Maybe those two. Let's see, what else would be good? Oh, maybe that one and this one. I need just 2 more is all. That one and this one. Okay, so these are the 4 that are rejected from the routine here. Okay, so with these cards, what I'm going to do is I'm going to mix them thoroughly using geometric shapes along the way. Okay, so the first thing I'll do is I'll go ahead and do something called a mange over under, which is a great way to scramble the cards. And now from here, I'm going to deal out the cards into a line segment. A line segment has 2 vertices. Here's a vertex, here's a vertex, and then you just draw a straight line between them. How would you like these stacked as the spectator? Right on left. Now, note to you as a performer, you can deal out the cards in this fashion as many times as the spectator would like, with random stacking decided by them. Maybe they want right on left again. Okay, so if they're content with kind of a line segment dealing, you can actually deal out the cards into a triangle configuration. So 3 vertices here, like that. And then we'll just stack them in the same order that we dealt them. In fact, I want to show you, you can also stack them in the opposite direction, starting with the last one. So you could ask the spectator, do you want me to kind of stack these counterclockwise or clockwise? Well, we did this clockwise just a moment ago. Now, if you do counterclockwise, you start with the last one and deal in that fashion. Okay? And then, see, another geometric shape here with 4 vertices is a square. Okay, here's a square. Okay, and you have a number of choices here. Would you like the bottom vertices stacked on top of the top, or vice versa? Top on bottom? Okay. And then how would you like these stacked? Left on right or right on left? Right on left. Okay. You can do as many of those as the spectator likes. You truly can. Okay. Maybe in order to keep the video from getting too long, we'll stop there, but you could do additional ones. And then from here, what we'll do is we'll just do another mange over under or under over. Spectator can choose that actually. And then we can perform kind of a final mixing here. This is called a Charlier shuffle. Okay, this is just a tremendous scrambling of the cards. I'll add a link in the description below to the Charlier shuffle if you want to learn it. And now we're going to deal out the cards into a hexagon, which has 6 vertices. Okay, so we're going to go like 1, 2, and then 3, 4, 5, 6. Oh, I went off camera. Sorry about that. 1, 2, 3, 4, 5, 6. Okay, so in camera view the whole time I have this written prediction. Now I just want you to think about this. What could I have possibly written ahead of time that I would accomplish when you chose 16 random cards for me to work with. And I chose 12 just so that we can keep the tedium down. How could I possibly write a prediction that would say anything specific about the outcome here? Okay, so let's just take a look at the prediction here. Okay, so what does the prediction say? There will be 2 pairs of cards of the same value within each pair. So like 2 aces or 2 sevens or something. Okay, so let's just see. Oh, we got 2 fives. That's one of the 2. Let's go over here. Okay, those aren't the same value. Those aren't the same. Okay, it's not looking too good. Those aren't the same. Oh man, we're getting down to the end, guys. Oh, we found another one. Okay, so we're just hoping that these cards are not of the same value. Oh, they're not indeed. So we got 2 red 10s and 2 black 5s. We nailed that prediction. Oh, yeah, there is more. You're right. There will also be 4 pairs of cards of the same suit within each pair. There's no way that could be true as well. Think about it. These are random cards, guys. Truly random. And this prediction would apply no matter what cards were selected. So is it true? So we got 2 pairs of the same value. We can check that off our list. In addition to that, we should have 4 pairs of cards of the same suit. Okay, so same suit, clubs, diamonds, clubs, hearts. We did it. 2 of the same value, and then 1, 2, 3, 4 of the same suit within each pair. That is a geometric miracle. Okay, so how do you do this? Well, really all I need to tell you is kind of what my selection process was. So let's kind of go back to the beginning, okay? And I'm going to bring out a write-up of the underlying mathematics. What's kind of interesting here and a little bit humorous is the mathematics driving this is not actually geometry. It's the pigeonhole principle. Well, that's part of it. That's what guarantees the pairings that we finish with. The mixing of those pairings in the way that I showed you, that's using principles that I teach on my channel. Okay, so first off, let's look at the selection process really quickly. Now, this is not complicated, I promise you. This is not, you can do this. Now, if you've never heard of the pigeonhole principle, that's okay. The simplest description of that principle is the following. If you have 3 pigeons, so imagine 3 birds, but there's only 2 pigeonholes, little places where those pigeons can sleep, okay? Well, if we know that all 3 pigeons are in one or other of those holes, those 2 holes, then it must be the case that one of the pigeonholes has at least 2 pigeons living together there. Okay, so this is really just an application of that principle to higher values and a more complex use of this involving playing cards. Okay, so let me just tell you what's true, and the mathematicians out there can verify my calculations just fine, but let me just tell you what's true. So given 16 random cards, this is what you can plan on being true. There will be at least, and all we need are 2 pairs of cards of the same value, like 2 10s and 2 5s or 2 aces or whatever. Okay, now there may be more than 2 pairs of that kind, but there will be at least 2 pairs, and that's what we're going to do. We're going to choose pairings. The first 2 pairings will be pairings where they match in value. That's what I did. And then beyond that, once you have those 4 cards pulled out of the 16, leaving you with 12, there's something else we know by the pigeonhole principle. Namely, there will be 4 pairs of cards of the same suit within each pair, which is exactly what we saw. Okay? And these are not probabilistic. This isn't, well, it might happen. these are factual. This will have to be the case for any group of 16 cards because of the pigeonhole principle. So it guarantees these outcomes, okay? And then for those who want to kind of look at the calculations, there are 13 distinct card values, 4 distinct suits. And so what I've done here is just kind of shown step by step what we know we can plan on being true. Namely, among the 16, there will be at least one pair that matches in value. You pull those out, leaves you with 14. Among those 14, there will still be one pair of cards that match in value. So you have 12 plus that one. So you now have 2 pairs that match in value within the pairs. Pull those cards out. Of course, you're down to 12 cards left. And then you just do the similar sort of thing for the suits. Okay, so you're just decreasing the numbers on the far left by 2 every time you pull out a pair. Okay, so you are guaranteed to be able to satisfy this prediction exactly as written, no matter what 16 cards you're handed. Okay, so that's the important thing. So the thing to do is, you're given 16 random cards. So 1, 2, 3, 4, 5, 6, 12, 13, 14, 15, 16. So let me just show you what I did, or what you can do is you just look at the cards, look for matching card values first. Now, if you can get ones that match in color, that's like a bonus. They don't have to, because we didn't say they did. So for example, we have 2 queens, same value, and they happen to match in color. So that's wonderful. So the first 2 I would have dropped to the table would be these. I don't know if I see, I do see another pair of card values that match and match in color. Now that wasn't, no, it was the case, I guess. It was the case for my performance, but it may not be that these match in color within these. The pigeonhole principle won't guarantee that in this specific case here. Looks like we even have 2 3s and 2 4s. That's kind of nice. Okay. That you could choose, but we just need 2 pairs that match in value. And now you're going to look for your pairs of matching suits. Okay. So you could pull this one out, drop it on the pile. So here's a pair of spades. You can come over here, maybe even grab both of these and say, okay, those work just fine. It's a pair of clubs. Let's see, maybe the 9 here of diamonds with the jack. You pull them off one at a time. That's a pair, same suit. And then we can go with the hearts here. King of hearts, 4 of hearts, leaving us with these 4 as a discard pile. Okay. Now it's important that you maintain these as pairs. Now what I did is I pulled them off one at a time to guarantee that the pairs were next. Cards within the pairs were next to each other. Okay. So in the language of the Absolute Math Magic channel, this is called an AMP, adjacent mirrored pairs. For those who have studied my channel, you can perform an under-over or an over-under. It converts it to a mirrored structure. Once it's mirrored, you have the stay stack principle, which says that for each divisor of the packet size, you can deal the cards into that many piles with random stacking from left to right or right to left if you're doing it in a linear fashion. Okay. But there's other dealing you can do that I showed you. So for example, of course, we can deal into 2 piles like this. It's fine. Random stacking. Okay. You can deal into 3 in this way if you'd like. I just was bringing in geometry here, a triangle. So if you're going to go clockwise, you pick up this one first. If you're going to go counterclockwise, you pick up the last one dealt first. Okay. And really, with the stacking there, you just do it. Or you give them the choice. Okay, should I stack clockwise or counterclockwise? And then you just need to know which one to pick up first and then follow their instructions. And then you can deal out into a square in this sort of way. So 4 vertices, right? Okay. And so what's kind of nice to do is just have them decide, okay, top row on top of the bottom or vice versa. Okay, that gets it down to 2 pairs and then random stacking here. And you can do as many of those as you like as well. And then all I did was another, this time maybe we'll do an over-under instead of an under-over, which is what we did at the start. A mange shuffle. It's now cyclic. Because it's cyclic, you can randomly cut it. You could even have the spectator randomly cut it if they like before you go into the hexagon dealing. Or you can do a Charlier shuffle. And then to finish, you just deal out into 6 piles. That's all you do. Okay? And then you bring out your prediction. If you remember, 2 pairs will match in value, and then the other 4 pairs will match in suits. Well, let's just see if that happened. Okay, well, we have 2 that match in suit. That's good. These match in suit. These match in suit. These match in value. That's one of our 2 values. Those match in suit, and these must match in value, and they do indeed. Okay, so this will work for you every time. It's using a lot of powerful principles, not only on my channel, but in mathematics itself. The Pigeonhole Principle is what's guaranteeing that we can get these pairings to work out the way that they do here. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.